Drawer construction. The next step to undertake in the construction of our night table is the construction of the drawer. Two types of drawers are usually used in furniture construction. These are flush drawers. Flush drawers close so the carcass and the face of the drawer are in line with each other. Lip drawers. Lip drawers have the face of the drawer rest on the outside of the carcass. If we examine the front elevation and the end elevation from the drawings of the night table, we can see where the night table was designed to be fitted with a flush drawer. Our cutting list, which was prepared for our drawing, gives us the size of the parts for the drawer. For this drawer, we will use lap dovetail for joining the sides to the front. It is called lap dovetail because the tail is set back by a small lap. The result is that the dovetail is visible only on the drawer sides and does not come right through the front. For the back, we will use butt joints to connect the sides and further strengthen with glue and nails. There are no hard and fast rules of how many dovetails will be used on the sides and how wide the tails and pins will be. In our project, we will use 3 dovetails on each side. Marking out the dovetail. The drawer side or tail will extend into the drawer from 12 mm to set a marking gauge at that dimension. Use the marking gauge to mark all around on one end of the 2 side pieces. Using the same setting on the gauge, mark a line along both ends parallel to the width of the piece. Also, mark lines on the face 12 mm from both ends using the mortise gauge. Mark points 10 mm from both corner of a side piece across the end. From each of those marks, measure 30 mm, and from those points 8 mm. Use a tri-square and square lines across the end. Use a sliding bevel to mark the sloping lines. Cut out the tails using a dovetail saw, then a coping saw, and clean up with a chisel. Clamp the drawer front upright in the bench vise and position a side piece on the front piece. The end of the pins should align with the gauge line. Use marking knife and mark out the pins. Flip over the front piece with other end upright and do the same with the other drawer side. Make a mark on each piece so that there is no mix-up when assembling. We will now proceed to cut the pins on the drawer front. Clamp the piece vertically in the bench vise and use a dovetail saw to carefully cut along the sloping line between the 2 gauged lines. Make several more cuts to aid in chiseling. Repeat at the other end. Then clamp the drawer front face up on the bench and use a chisel to clean out the waste. We will use the table saw to make the groove for the plyboard bottom. Set the fence 16 mm from the blade and set the blade height at 6 mm. Cut the groove on the front piece and the two side piece. Adjust the fence to widen the groove to 6 mm wide. Fix the drawer parts. Bore pilot holes in the drawer sides for the butt joint. Apply glue to the parts and assemble. You may need a clamp to temporarily bring the joints tightly together. Use a hammer to drive two 38 mm finish nails to fix the sides to the back. Remember to check diagonals to ensure the drawer is square. Remove the clamp and let the glue set according to the manufacturer's recommendation. After the glue is set, cut the plyboard bottom and slide it in the groove from the back. Screw the plyboard to the back. The drawer is now ready to be fit in the carcass. Fitting drawers. The back of the drawer is inserted in the opening. From then on, use a plane and gently ease any tight spots until the drawer operates smoothly. The base that will be constructed for the night table consists of 4 legs connected together with nails stretched between them. Another name for this type of base is carcass stand. Select material for the legs from 50 mm thick stock. Plane and cut the stock to produce 4 pieces measuring 34 mm by 34 mm by 150 mm. For the connecting rails, prepare material to produce 2 pieces of dimension 326 mm by 50 mm by 18 mm and 2 pieces of dimension 256 mm by 50 mm by 18 mm. Marking the joints. The rails will be flush with the legs, so this necessitates that bare-faced tenons be used. This type of tenon only has one shoulder. Use your marking gauge and mark on the face. Shoulder lines 25 mm from the end of each of the rail. Continue these lines onto the edges. The thickness of this type of tenon are usually half the thickness of the board, so set the marking gauge 9 mm and mark lines on the edges from the shoulder to the end of the rail and connect these lines. Select 2 adjacent faces cutting the mortise on each leg. Measure and mark off 50 mm and 12 mm on the selected faces, starting at the top of the legs. Then use tri-square to mark parallel lines across the adjacent faces. Set the spurs of the mortise gauge 9 mm apart and the stock 9 mm from the spur, and mark lines between the two parallel lines on both faces of each leg. Clamp the rails in the bench vise and use a tenon saw to cut out the tenon. Each leg is then clamped in the vise. Then a 9 mm chisel is used to cut out the mortise. Use the table saw to make a groove 12 mm from the top edge, 6 mm wide and 9 mm deep in all 4 of the rails. This will allow the use of wood buttons to fit the base to the carcass. Shaping the legs. On all 4 faces of a leg, mark points 8 mm from each corner. Use a tri-square and mark a line all around the 4 face at midpoint, which is 75 mm from the ends. Use a straight edge and connect the points at the end of the leg to the corners of the line. Use a band saw to cut the shapes of the legs. Do not cut directly on the line. Cut a few millimeters away. Also, do not cut off the waist completely on 2 adjacent faces to avoid cutting the glue lines. When all 4 faces have been cut, you can then cut off the waist. Use a smoothing plane to smooth out the cuts and to glue lines. Dry fit the base and make any necessary adjustment. Assemble as follows. Apply glue to tenon and the mortise. Then use a sash clamp to hold the joints together until dry. Top. Select, cut and dress a piece of board to a finish size of 300 mm by 400 mm by 20 mm thick. Set a compass 25 mm and mark out the arc on the 2 front edges. Use a flat bottom spoke shave and smooth out the curve. We have now completed all the components of the night table. Now that the carcass, the base, and the top is constructed, we will proceed to fix them together. When fixing solid timber together, you should always bear in mind that wood expands or shrinks depending on the humidity in the atmosphere. Also, the movement is mainly perpendicular to the direction of the grain. Movement in the direction of the grain is negligible. Fixing the top. To account for shrinkage of the solid top, the front will be screwed to the front connecting rail and the back will be screwed through slots in the back rail. Using a drill with a 6mm bit, bore 2 holes in the front connecting rails, about 50 mm in from the sides. Similarly, bore 2 holes in the back rail. To create the elongated holes, move the drill forward and backward until the slot is formed. Examine the top piece and place the less attractive face up on the workbench. This will be the underside of the top on the finished night table. Position the carcass top on the top piece. The back of the carcass should be flush to the back of the top piece and the sides should have equal overhang. Screw the front using 30mm long wood screws. Place the screws in the center of the slots in the back rail and drive in the screws. Do not over-tighten these screws so as to allow the top pieces to move. Bore a hole in the center of the drawer front. This is to facilitate the fixing of a knob. However, it is best to install the knob when the finished material is applied to the furniture. Fixing the carcass to the base. Use the table saw and make a tongue 9 mm long by 6 mm thick on a piece of board measuring approximately 32 mm wide. Cross-cut the board about 30 mm to produce the 6 individual buttons. To fix the base to the carcass, wood buttons will be inserted in the grooves made in the rails. 6 buttons will be used, 2 on each of the long side and 1 on each of the short side. The thickness should be slightly less than 18 mm, so when the buttons are inserted in the groove, it will be set slightly below the top of the rail. This will allow the base to be drawn tightly to the carcass when screwing. Bore a 6 mm hole in the center of each of the buttons. Insert the buttons in the groove in the base. With the night table turned upside down with bottom face up, place the base on the carcass. Both structures should align perfectly as they are exactly the same width and depth. Drive 30 mm long screws through the wood buttons. Ensure that a gap is between the buttons and the rails. Preparing the surface. The choice of finish is especially important, but yet the simplest part. Preparing the surface correctly is crucial to achieving a fine finish. After assembling the project, check it carefully to make sure it is smooth and free from imperfection. A finish never covers up dried glue, ridge, dents, chips, gouges, or scratches. Instead, these flaws and defects will show more clearly after the finish is applied. Therefore, it is important to follow proper surface preparation before finishes are applied, such as to remove excess glue, to remove mill marks, to correct defects. Fill small holes or chips using wood filler that matches the wood use. You can make your own wood filler by using dust produced when sanding and mixing it with sanding sealer. Sanding. It is especially important to sand the wood as smooth as possible before applying any finish. Open coat aluminum oxide paper is generally preferred for sanding furniture. Sand with progressively finer grits, starting with medium or fine, 100 to 180 grit. When sanding, remember to rub along the grain. Sanding across the grain will cause scratches that will show through the finish. For ease, efficiency, speed, and accuracy, a belt and/or orbit sander can be used. After sanding, remove fine particles and dust by wiping or brushing the wood. When hand sanding, hold the paper flat and use a wood block whenever possible. Keep the paper clean. This can be achieved by slapping it against the bench to get the dust out. If you damp the surface by wiping all over with a clean rag soaked in clean water, then this will raise the grain, which is then sanded down again using very fine sandpaper. Staining. The application of staining is a very widespread means of wood finishing. It is usually done to create color, so that the piece of wood matches an existing piece of woodwork, or to enhance the appearance of a lesser attractive wood. There are two main types of stains, water-based and oil-based. Stain can be applied using a soft cloth, brush, or by spraying. In our project, we will use a brush to apply the stain. Brush on a generous amount of stain on the wood piece. After a period of time, which is usually suggested by the manufacturer, use a clean soft cloth and wipe off the excess stain. This is a very important step because if the excess stain is allowed to dry on the workpiece, it may cause the piece to have inconsistent color. It can also prevent subsequent finishes from adhering properly. Allow the stain to dry completely depending on the manufacturer's specifications. This time period can be between 2 to 24 hours. Sealing. The next step is to apply a sanding sealer to the workpiece. The purpose of sealing is to fill the pores to create a completely smooth surface that will absorb relatively little of the finishing material. It is especially important in softwood, such as cedar, which will absorb a lot of the finishing material. Sanding sealer also makes sanding between coats much easier. The method generally used to apply sealer is spraying. Use the following guidelines. Wear a respirator, goggles, rubber or vinyl gloves, and clothing protection when spraying. Spray in a well-ventilated room or outdoors in an area protected from wind. Mix the sealer and thinner in 1:1 ratio. Use a spray gun connected via a hose to an air compressor and apply the sealer. Keep the nozzle of the gun between 200 mm to 300 mm from the workpiece and hold it at a 90-degree angle. Spray on at least 2 coats and sand thoroughly after each coat with a 240 grit sandpaper. Application of lacquer. Lacquer is a finish composed of nitrocellulose, resins, and solvents. It dries quickly and produces a hard finish. Most commercial lacquer finishes are applied by spraying. Some lacquers are formulated for brushing, which is usually used on small projects. Brushing on lacquer that is made for spraying is not recommended because the drying time is very short. In this particular project, we will be using the spraying method of application. Make sure the compressor is in good working order and the spray gun is clean and functioning properly. Mix a solution of 1 part lacquer to 1 part lacquer thinner. Clean the surface with a rag. You can also direct the high-pressure air from the compressor to blow out the dust. Put on your respirator mask, goggles, gloves, and clothing protection. Fill the spray container with mixture of lacquer and thinner. Test the spray gun on a piece of scrap or paper. It should spray with a fine, even mist. Move your arm, not your wrist. As you spray, keep the gun at a right angle to the surface. Keep the nozzle of the gun between 200 to 300 mm. Begin the stroke before pulling the trigger and release the trigger before ending the stroke. Overlap the strokes about 50% using alternate left and right strokes. Spray on 4 or 5 coats of thin lacquer. After you have finished, clean all equipment with lacquer thinner. Cleanup. In the event of practicing safety, it is always important to remember that the job is not complete until you have cleaned up your work area. It is also important to remember to maintain and store tools, machines, and equipment in a safe area. When the lacquer is completely dry, you can now screw on the knob to the drawer front to complete the night table. Cutting, smoothing, and boring tools. Section 1. At the end of this section, you should be able to A. Discuss the types of hand saws, and B. Discuss some types of smoothing tools. Apart from marking tools, the next category of important hand tools used for woodwork are cutting, smoothing, and boring tools. Among the cutting hand tools, hand saws are important tools for woodwork. Hand saws. There are many different types of hand saws, each for specific applications. A hand saw has two main parts, the blade, which is made from cast steel, and the handle, which is made from wood or plastic. Saws are classified on the basis of their length and the number of teeth per inch, TPI. The total length of the blade, excluding the handle, determines the length of the saw. The cut that is made by a saw is called kerf, and it relates to the width of the cut. Saws with a small TPI give a coarse and wide kerf, while saws with more TPI give a smooth and narrow kerf. Saw teeth are usually set in such a way that these are slightly bent alternately. The teeth of the saw and the way they are set make the kerf wider than the thickness of the blade, thus reducing friction between the blade and the wood. The following are some common types of hand saws. Saws for cutting straight. The rip saw. The rip saw is the longest hand saw, with its blade usually ranging from 620 millimeters to 700 millimeters. The rip saw usually has 3 to 6 TPI and is used for ripping, i.e. cutting along the grain of wood. Crosscut saw. The crosscut saw looks similar to the rip saw. This saw has usually a blade of length 500 millimeters to 650 millimeters and has 6 to 8 TPI. The crosscut saw is used for cross-cutting, i.e. cutting across the grain of wood. Tenon saw. The blade of the tenon saw can be 200 millimeters to 450 millimeters long and carries about 10 to 14 TPI, or we can say 10 to 14 teeth per 25 millimeters. It has a folded strip of brass or steel clamped over the top edge of the blade in order to prevent it from twisting or buckling during use. The tenon saw is sometimes referred to as the back saw. Dovetail saws. A dovetail saw is like a small tenon saw. It is available in length up to 200 millimeters and has 12 to 16 TPI. It is used for fine and accurate work such as model making and dovetail joints. Saws for cutting curves. Some of the saws used for cutting curves are, for example, coping saw, bow saw, keyhole saw, pad saw, and compass saw. We will state the features of coping saw and compass saw. The coping saw. The coping saw is a small saw with a thin, narrow blade that is about 3 millimeters wide, 170 millimeters long, and has about 14 TPI. This blade is held in a springy steel frame by 2 studs and are loosely held in the frame to allow the rotation of the blade to assume convenient positions. Compass saw. The The compass saw has a narrow tapered blade with length ranging between 300 millimeters and 400 millimeters and having 8 to 10 TPI. The narrow blade allows the saw to perform its function of making large internal cuts, whether these are straight or curved. Smoothing tools. Smoothing tools are those tools used to refine the texture of a piece of wood or reduce it to a required size by means of shaving off the waste. Smoothing tool consists of planes. The planes can be divided into two types. 1. Those used to produce a flat surface. 2. Those used to produce a rebate, plow groove, molding, or curve. Plane safety and maintenance tips. The following precautions should be taken in consideration to guarantee safety and proper maintenance of planes. 1. Use the appropriate blade for the work at hand. 2. Always keep the blade sharp. 3. Lightly oil the working surfaces of planes after use. 4. Rest the plane on its side when not in use to protect the cutting blade. 6. Store the plane with its cutter retracted to avoid premature edge wear. Flat surface planes. There are 3 main types of flat surface planes. All 3 have the same type of cutting unit, which consists of a cutting iron, cap iron, and lever cap. These planes are adjusted by means of a lateral adjustment lever which adjusts the angle of the blade, and a depth adjustment knob which adjusts the depth of the cut. Section 2. At the end of this section, you should be able to A. Discuss the types of planes and pairing tools. The joiner plane. The joiner plane is sometimes referred to as the triplane. It is the largest hand plane with length ranging from 450 millimeters to 600 millimeters. The extra length of the plane allows it to do its job of straightening the edges and surfaces of long pieces of wood. Application of the joiner plane. Straightening a piece of wood. Use a vise to clamp your work, giving the worker the freedom to hold both toe and handle. Tilt the board a little so that you will be planing just slightly uphill. Set the plane blade depth with the adjusting knob found behind the toe handle. Grip the toe and heel knobs firmly. Push the plane along the wood with long, smooth strokes. Press a little harder on the toe at the beginning of the stroke and a little harder on the heel at the end of the stroke to avoid overplaning at the ends. Check the cuttings. The curls should be paper thin. If they are thick, your blade is set too deep and you need to adjust it. The jack plane. The jack plane is similar to the joiner plane, except for the fact that it is shorter, having a length of 375 millimeters. It is mainly used for reducing timber to the required size and for all rough planing. Being an all-round general-purpose plane, it is ideal for both site and bench work. The smoothing plane. The smoothing plane is similar to the jack plane with the exception of the fact that it is shorter, having a length of 250 millimeters. This type of plane is used for taking the final shaving from wood, smoothing up the job before glass papering. Planes for irregular shapes and surfaces. The planing of irregular surfaces is oftentimes required. Among those irregular surfaces are curves, rebates, and grooves. Special hand planes are designed to plane these irregular surfaces. The spoke shave. The spoke shave is another type of smoothing tool. Two main types are flat bottom type and curved bottom type. These are used for the final work on curved surfaces. The blade of the spoke shave is adjusted by means of screws and is held firmly in position by a locking cap. Paring tools. Among the paring tools used by woodworkers are chisels. Wood chisels are usually sharp and must be used with great safety awareness. Safe use of chisels. The process of cutting with a chisel is called paring. Chisels may be used for horizontal paring and vertical paring. A wooden mallet should be used to strike the chisel. Some basic safety precautions to observe when using a chisel are: 1. Always keep chisels sharp. A dull chisel is dangerous as it requires excess force to cut the stock, and the use of excess force can cause the chisel to slip. 2. Always pare chop away from the body. 3. Keep your hands behind the cutting edge of the chisel. 4. Always carry chisels with the cutting edge pointing down. And 5. Never carry chisels in your pocket. Types of chisels. There are several basic types of chisels. Each type has its intended purpose. Firmer chisels. Firmer chisels are designed with a rectangular blade and are available in sizes ranging from 3 millimeters to 50 millimeters. These chisels are very strong, which makes it suited for all different types of wood, including heavy chopping. Mortise chisels. Mortise chisels are narrower than firmer chisels, but they have thicker blades, which makes them stronger. Mortise chisels are available in widths ranging from 3 millimeters to 25 millimeters. As the name suggests, this type of chisel is used for cutting mortises. Bevel-edged chisels. The beveled edge chisel is sometimes referred to as the beveled firmer chisel. It is basically a firmer chisel with bevels on the front edges of the blade. The beveled edges makes the chisel suited for working in corners less than 900 millimeters, such as dovetails. They are not as strong as the regular square-edged firmer chisel and should not be used for heavy chopping like the firmer chisels. Gouges. Gouges are similar to chisels except for the fact that their blades are curved to give a cross-section resembling a semicircle. They are mainly used for shaping, carving, and scribing. Two main types are scribing and firmer gouges. Boring tools. These tools are referred to as drills, even though the electric drills are more popular. Sometimes hand drills such as the wheel brace and ratchet braces are used for simple applications. Drill bits. An important part of drilling is selecting the appropriate bit for the job. Factors that affect the section of a bit are the circumference of the hole and the density of the material you want to drill. Let us look at some drill bits and their intended uses. There are several types. Two common types are: 1. Twist bit. The twist bit is sometimes called the auger bit. 2. Countersink bit. The countersink bits are small bits used to make a recess in the surface of the wood for receiving the head of countersink screws.